Hi, everyone. As Megan said, I'm going to talk about applying AI chatbots with Charliecloud. First off, I want to say that I didn't do this work alone. I have some co-authors, Tolu, Phil, and Mike. Their names will come up later, as I start talking about the ongoing work with this project. The motivation for this project is to develop a chatbot to support our HPC users. I'm in the HPC division at Los Alamos, and we have a team of consultants that users can directly contact with some common questions like, how do I connect to the cluster? What are the memory specifications of the nodes? The consultant's favorite, why isn't my job running? And of course, some Charliecloud questions as well. And on the right side of the screen, I have a mock-up of such a system where users could maybe choose different users, or perhaps consultants could choose different large language models, maybe adjust them somewhat, and ask questions that hopefully would be tailored to our systems. So it would give you maybe information that's specific to our systems as opposed to general solutions that maybe wouldn't work because of whatever configurations we have going. There's many challenges with standing up such a model. One of them is that, at least at our organization, it's difficult to get an OpenAI key and hit their API to stand up one of these chatbots. So it has to be done locally, and we're not, OpenAI. We don't have, we may have, nodes and clusters. We don't have entire data centers or regional networks of data centers dedicated to this. We can't run GPT or one of the reasoning models locally, maybe. And we can assume under the hood, we've got Kubernetes running Docker containers. Maybe that's not accurate, but I think it's a safe assumption. So what are you going to do when you don't have that regional network of data centers? Instead, you only have maybe one standalone box here. I've got a picture of a DGX standalone box that seems to be popular. You can buy it off the shelf. And then I've got a picture of our open science cluster at Los Alamos called Chacoma that has GPUs. So what would you use for a model? How would you drive that model? What software would you use? And what container runtime would you use? I think maybe you can guess what the container runtime will be. When we started this project, one of the challenges is the large language model ecosystem is super complex. I found this network diagram by a group at Stanford that sort of mapped out all the data models and tooling. And if you zoom in, you can see maybe some things that are recognizable, but even after maybe a year in this space, I don't know all these tools. So what would you choose? We were tempted at the beginning. I think it's probably tempting for anyone to use one of these all-in-one applications. So NVIDIA has a chat RTX tool. There's other sort of mega company affiliated tools like anything LLM or GPT for all. And they all promise sort of an all-in-one solution. You download one executable, you run it, and it handles everything in the background. It gives you the back end, the front end, everything. One challenge with that is it's not very flexible, and certainly it wouldn't be probably a good idea to try to run them at scale. So for the case study I'm going to describe, I'm going to go through our choices of model, software, container that our data center sort of set. And one of our requirements was to not send any data to the companies for training. I think that's a common concern. So the model we chose was Mistral, partly because we'd seen benchmarks with Mistral. It was something we were allowed to run. It's got a small footprint. Seemed like a safe choice. That choice is sort of up for debate. The good thing about splitting it out this way, especially with how we chose our software, sort of in contrast to the all-in-one solution, it'll have a lot of different pieces. So for our software, we chose this VLLM runtime, which seems like the far and away the leader in this space. There were other parts of our software stack, like this Milvus database that maybe is one of the leaders, but that's up for debate. And having it split out this way means that should some tool comes along that maybe supersedes VLM or Milvus or another tool we use Llama Index, it would be easy to drop that in. Just build in a path to stay current versus one of the all-in-one solutions where you're sort of locked into an entire ecosystem. And then finally, our container runtime. Maybe you can guess that would be Charliecloud. So I'm going to demonstrate sort of the process that, how do you use Charliecloud to spin up one of these systems, and maybe some tips and tricks and ongoing work in the rest of the talk. In summary, we've got this Mistral large language model. It's a 7 billion variant, which means it's fairly small. One advantage is you don't have to worry so much about, for this testing at least, you don't have to worry so much about setting up parallelism or spreading the model across different nodes or GPUs or anything like that. You can just sort of test to see if you get baseline reasonable results. We used a technique called Retrieval Augmented Generation, where you tell the large language model, don't give me general answers. Instead, you give it a database, in this case, hosted by this Milvus tool, and use that database as context. So constrain your answers to a universe of, in our case, internal documentation, external documentation, and user support tickets. The idea being with this tool that it could act sort of as an aid for consultants, or potentially, I think of it like an FAQ that's updated automatically, hopefully. And for our hardware, for the tests I did, it was just single node, both server and client, one A100 GPU with VLM sort of doing that orchestration for you. And then the Charliecloud container runtime. So there's some setup steps on what you would do, like just starting out to get such a system running. From the Charliecloud perspective, the image we used was this BLM image. So once you have Charliecloud installed and working in the general case, you would need to, in our case, pull from Docker Hub. And on the first line, I'm tagging it very simply just as VLM. And then the second line, I'm converting that container that lives in memory to be at rest in a squashfs format. And then finally, I'm running that squashf, or then on the third line, I'm checking out a GPU node. And then the next three lines are all dealing with injecting the NVIDIA libraries that are on the node into the container so that everything's matching and there's no sort of version conflicts. And then on the last line, because this is a one-time setup, we're doing all that document ingestion. So we've got a whole folder tree of our internal documentation, external documentation, user support tickets, and we're ingesting that in the Milvus database. But then in subsequent steps, in our case, Llama Index, and we'll be reaching out to the Milvus database to retrieve context to respond to the queries. After you've done that one-time setup, you of course want to use the system. So first line, we're checking out a GPU node, and then we're running that squashfs container that we set up in the one-time setup. Step on the previous slide. We're using the chrun command, and we're using the CD flag there, which in my mind is equivalent to the work dir, I guess. And we're bind mounting our current directory, which has all the Python scripts I mentioned earlier, dropping us into a bash shell. Once the container is up and running, we're starting that, the VLM server process and shoving that into the background, and then starting the front end app. then sort of will be system specific how you get to view that. But in our case, we're tunneling to the compute node and opening our front end app in the browser, which I will then, before I get to that, talk about bind mounting a little bit. A lot of the components that go into this are big. So the Mistral 7 billion model is not that big. It's still sizable, but if you were to try to use a larger model, you're going to want to download it every time. And so you want to be careful about sort of downloading it a single time and storing it somewhere and then bind mounting. So the top line I'm showing sort of inside the container where it expects the model to be. And that's in our case, we're using Hugging Face. It expects it to be in a .cache folder. So you might store that .cache folder somewhere else, in our case, in a scratch file system that's large, and then bind mount that into the expected location inside the container. Now some results. These can be kind of fun. One question is, I have on this first slide, is how do I check my file system quota? And I specifically chose this question because if you were to ask a general tool, like maybe regular ChatGPT, it would give you an answer that wouldn't work on our systems. It would probably tell you to use the quota command. And at Los Alamos, we have these homegrown utilities to check your file system quota, check proj and check home. And so this slide here demonstrates how it's actually using the context that we gave it and giving us answers that would be specific to our systems rather than general solutions that wouldn't work. Another example, this is the consultant's favorite. What are some reasons why my job isn't running? And this gives you very accurate things to our system and sort of summarizes past consultant interactions with users to some extent. And it gives you ways to check the status of your job that's specific to our systems, which use Slurm, and it gives you Slurm commands to track. How do I change my default shell? That's another common question that the consultants get. And this, similar to the two questions ago, this was specifically chosen because if you asked a general tool, it will give you an answer that wouldn't work on our systems, or at least it wouldn't work on a persistent basis. We'll probably tell you to use the change shell command or chsh. And on our systems, you set your default shell in our account system. So this tooling gives you, again, information that's specific to our systems. How can I upload a Charliecloud container to our registry? I'm showing the results of this partly because it's very long. You can see it's cut off at the beginning. And I included this to make the point that sort of there's endless tweaking you could do to these type of tools. In my estimation, it gives you ch image push, which is accurate, but it could be more concise. And so maybe there's adjustments that can be made to the sort of the system level prompt, or the context length of the model, or sort of endless things you could tweak. Maybe a larger model would give a better result. And we'll see later that some of the answers go the opposite direction. They give, some of the answers the opposite direction, they're too short. They don't give you enough information. The next question, how do I launch a Slurm job on 10 nodes? I included this just to prove the point that it can give general information. I believe we did feed it context on like the Slurm documentation, so that makes sense, but it can give you information that is not specific to our systems. So, checking out 10 nodes likely is pretty similar on every system that's using Slurm. How do I get an account on a cluster? I include this question, just because this is a common question that consultants get. But on our systems, for the most part, it's not a self-driven thing where you sign up, you sort of request an allocation or join someone else's project. For the remainder of the talk, I'm going to go over sort of my general conclusions about the project and also mention some ongoing work. One general conclusion is that we saw comparable performance to generic cloud resources. So similar to what I think has been seen with Charliecloud in the past, it's had a minimal performance impact. The table I'm showing is not my table. It's from the GitLab documentation about what they saw running the same model on generic cloud resources. And I don't have the numbers on the slide, but I can just tell you that the average tokens per second per request, which is like a common benchmarking metric, were very similar. In fact, even better than these generic cloud resources, at least slightly. Maybe in the 140, 160, up to 200, depending on the request. Some ongoing work. This is where my talk co-authors come in. Tolu, Bill, and Mike. They're really involved in UI design. So we have this mock-up that I showed at the beginning, and they're continuing to work on improving this front end and also all the stand-up work that goes on behind the scenes. So load balancing, optimization of different things. And then some other ongoing work is getting that's relevant to this project is hooking in Charliecloud to Kubernetes so that Charliecloud could be used as a runtime. And one of my first slides, I talked about what I presume is the OpenAI setup, where they're using Kubernetes for auto scaling. The idea here is you wouldn't check out a node like I did and just sit on that node. You would have as a persistent process. Instead, depending on the demand, Kubernetes could start containers and scale up and down the number of pods that users could be hitting with queries. And my colleague Angelica is giving a presentation, I believe, later in the session on exactly this, and ask her questions about that. Finally, I want to say that my conclusion is that Charliecloud is AI ready, not just in this project, but sort of in general. I've seen quite significant AI projects using Charliecloud to great success, and that I found that standing up an AI chatbot with Charliecloud is possible and useful.
Thanks, Jemma. Does anyone have any questions for Jemma? Yeah, Nick.
So also here is in Charliecloud. The images recipes that we found online tend to have multiple users that it sets up. Images that are not compatible with Charliecloud. Have you found, at least, I've also been building rock, so it's also outside the exact scope that you're working in, but have you found any of these kinds of issues you've had to work with?
Megan, maybe you could repeat the question. It kind of broke up.
Yeah, do you just want to come closer to the mic?
Sure. So, I mean, I assume definitely.
It is.
Yeah. I've also tried containerizing VLLM with Charliecloud and maybe with NVIDIA, but they contain things like multiple users are setting up and mounting in scratch spaces in ways that are not compatible with Charliecloud. Have you had to deal with any of these issues? And if so, what do you do to overcome them?
Yeah, unfortunately, I can't really answer that question, partly because I'm not involved in the production stand-up that would involve multiple users. That's sort of what my colleagues are doing. As far as bind mounting in ways that are not compatible, I'm not sure what that would be. Maybe if you could give a specific example of something that's not compatible, but for myself, I haven't run into that issue. I would say one challenge is that maybe outside of this project is sometimes you don't know ahead of time, you know, what paths inside the container are like writing out data. So that's why I include that slide, tips for bind mounting. Sometimes there'll be a directory you didn't know is like writing out a ton of data, and that will crash your process if you haven't bind mounted it to somewhere outside the container.
Yeah, question how in chat. Okay. Yeah, Jemma, there's one from Reed in chat saying, is there any privacy concerns with using support tickets as input?
Privacy, yeah, that's something that a lot of work has gone into, filtering out potentially sensitive information. There's kind of a hot topic in large language models where people are trying to deal with the issue of memorization. So what we don't want is for the large language model to repeat verbatim one of the user support tickets back to an unrelated user. So there's a good amount of data engineering that goes on. First of all, to deduplicate tickets, because the research is showing that high amounts of duplicated information leads to more memorization and more repeating of tickets verbatim. So I think current iterations, what I'm showing here is past work, but I think the current iteration of the tool has quite a bit of processing to the user support tickets to try to avoid that issue.
Anyone else have any questions for Jemma?